In the next two examples, we're going to take a look at common factoring. In our first example here, we have 3x cubed minus 6x squared plus 18x to the 4. The first thing that I tend to do when looking for a common factor is to see if there's a common factor within the numerical coefficients only. So in this case, I'm focusing on 3, negative 6, and positive 18. 3, negative 6, and positive 18 all share a common factor of 3. So we can remove that number first. Then we can move into the variable portions of our terms, that is x cubed, x squared, and x to the power of 4. Here we take the lowest power of our variable pieces, or in this case we take x squared as part of our common factor. Now we can go back term by term and divide out 3x squared. 3x cubed divided by 3x squared is x. Then we're going to subtract 6x squared divided by 3x squared, that's 2. And finally we add 18x to the power of 4 divided by 3x squared, and that is 6x squared. Now it's fairly customary to take this polynomial that we have inside the brackets and rewrite it in decreasing powers of our variable x. Now some of you may notice that we have a trinomial in here, and it might be possible to factor this trinomial. But for right now in our example, we're just focusing on common factoring, so I'm not going to factor this quadratic term. We'll take a look at how to tackle factoring quadratic terms a little bit later. In our second example, I'd like to show you that it is possible to pull out what we call a binomial factor. So if we have the expression x plus 2 all squared minus 3 times x plus 2, we could look at each of our two terms, our x plus 2 squared and our 3x plus 2, and we might notice that each of these terms has a common factor of x plus 2. So if we pull out this common factor of x plus 2, we might ask ourselves, what is x plus 2 squared divided by x plus 2? And what's remaining after we do that division is x plus 2. And then next we could move over and do the division 3 times x plus 2 divided by x plus 2, and ask ourselves what's left over after we do that division, and that is simply the 3. And we could simplify our second bracket a little bit to get x plus 2 times x minus 1. In our last example, we saw that it's possible to factor out a binomial factor. This leads us to another technique called factoring by grouping, where we're going to pair up two terms together, take out a common factor from each of those pairs, and see if we can get a common binomial factor. An indication that factoring by grouping might be helpful is if you have an even number of terms. In this case we have 4 terms, and I'm going to group together the first 2 terms and the last 2 terms, and try to find a common factor from each of these pairs. Inside of our first pair, note that we can take out a common factor of x squared. That's going to leave us with x plus 2. Inside of our second pair, the common factor we can take out is 8, and that's going to leave us again with x plus 2. Now that we've taken out a common factor from each of these pairs, notice that we have a similar binomial factor. So we can go ahead and take that out as a common factor, and then we're going to be left with x squared plus 8. Now you might wonder here if x squared plus 8 is going to be factorable. In this case it's not, because it is a sum of 2 squares. So this is our fully factored expression. Let's take a look at one final, more challenging example of common factoring. One where the exponents of our variables might contain a fraction. Well, first thing you want to do in this case is look at all of your terms and see if there is a numerical common factor that we can take out. In this case, looking at the coefficients, we have 2, minus 4, and positive 8. We can take out a 2 from all of these terms. Next, you want to take a look at your fractional powers. 7 over 3, 5 over 3, and 2 over 3. What we're looking for is the lowest common factor, and that's going to be x to the power of 2 over 3. That's the smallest of these three fractions. So let's go ahead and finish this up. If we factor out 2x to the 2 over 3 from our first term, we should be left with x to the 5 over 3. Now why is this? Well, that's because when we multiply these two terms, we're going to add our exponents together. 2 over 3 plus 5 over 3 is equal to 7 over 3. Our next term, after we factor 2x to the 2 over 3 out, is going to be negative 2 times x. Now why is this the case? Well, let's go ahead and multiply these two terms together. 2 times negative 2 will give us our negative 4. And when we multiply our two x's together, we're going to add our exponents. 2 over 3 plus 3 over 3 is equivalent to 5 over 3. And finally, our last term after factoring should be 4.